A very warm welcome, students. Today on my classroom, we will be talking about divisions and distributions, a very important concept in permutations and combinations. So, let's talk about divisions and distributions. And where do you use divisions and distributions? For example, you have 10 things and you want to distribute among 3 persons. This is the concept. And you have 10 things and you have to distribute among 3 persons ABC such that A gets 2 things, B gets 3 things, C gets 5 things. Again, this is the question on divisions and distributions. So, there will be variety of questions in divisions and distributions. Whenever you are reading a question on division and distribution, these are the following things you have to keep it in mind. First and the foremost, whether the objects which you are distributing are identical or distinct. There will be a lot of varieties of questions in divisions and distributions, and to not confuse between any one of them, you have to read the question very carefully, and these are the 3 things which you have to keep in mind. First and the foremost, whether the objects which you are distributing are identical or distinct. And second thing, whether you are putting these things in identical boxes or different boxes. Like if you are distributing among persons, obviously persons cannot be identical, they are all different. If you are just making them into groups without order being important, then the boxes are identical. If you have identical boxes and you are putting into them, that is identical boxes. Then are the sizes given to you? That's 10 things. Are you able to freely distribute among A, B, C as you like, or A is to be given 2 things, B is to be given 3 things, or C is to be given 5 things. So, whether they are sized or unsized, whether the group sizes are mentioned or not. And whenever they are sized, one more important thing we have to keep in mind is whether the sizes are equal or unequal. Sized, unsized, and when the sizes are equal, you have to be a little more extra careful. You have to also consider the case where the sizes are equal or unequal. So, instead of having this confusion, let us plainly put things on a mind map. Whenever you are having a question on distribution and division, you have to look at 2 things, whether the objects are identical or distinct. So, most part of the identical will come under multinomial theorem. I will deal with it later in next video. Distinct things. Whenever you have distinct things, next immediate question which you have to ask is whether the sizes are given in the question or the sizes are not given. Not given, absolutely fine. Sizes if they are given, then you have to ask one more question, whether the sizes are equal or unequal. When the sizes are equal, you have to again check whether the boxes are identical or distinct. When the sizes are unequal, it does not matter whether the boxes are equal or identical or distinct, but when the sizes are equal, it matters a lot whether the sizes boxes are identical or distinct. So, distinct objects are identical objects. Identical objects will fall under multinomial theorem. Distinct objects, whether the sizes are given or not given. If they are given, equal sizes or unequal sizes. Unequal sizes, happily you can do the question. Equal sizes, you have to again ask a question whether the boxes are identical or distinct. So, one by one we will go to each one of these question models. Whenever you are distributing distinct things of unequal sizes, let us say I have to distribute m plus n things all different among 2 persons or 2 different groups m and n. This can be done in m plus n factorial by m factorial into n factorial whenever m is not equal to n. Whenever m is not equal to n, I can divide m plus n things, different things, into 2 groups or among 2 persons or in 2 boxes of size m and n. Sizes are given here, m and n, in how many ways? M plus n factorial by m factorial into n factorial. Only thing is m should not be equal to n. How do we get this? Very simple. I have 2 boxes. I have m plus n things. I have to give to this box m things. So, out of m plus n, I will choose m things for this box. Automatically remaining n will go into this box. So, in how many ways I can make a choice? M plus n, C, n. and m plus n, Cn is nothing but m plus n factorial by m factorial into n factorial. Next, let us say I have m plus n plus p things and I have to and they are all different and I have to divide them into 3 different groups sizes m, n and p. So, one box has to contain m things, another box has to contain n things and a third box has to contain p things. Or if I am giving it to persons, first person will get m things, second person will get n things, third person will get p things. In how many ways this can be done? M plus n plus p factorial by m factorial into n factorial into p factorial. And remember, this is for m not equal to p not equal to n. Whenever any two are equal, it will be, again we have to check whether the boxes are identical or distinct. Okay. Now, how do we get this? From m plus n plus p things, I am selecting m things for A, Cm. From the remaining n plus p things, I will select n things. So, n plus p, C, n. Remaining p things will automatically go to C. So, it will be m plus n plus p, Cm into n plus p, Cn into PCP. It will land out to this particular expression. So, this is when all the things are distinct and sizes are given. Now, if the sizes are equal, what happens? M is equal to n or m is equal to n equal to p or any two of them are equal. Let us say you have 2n things to be given among 2 persons or 2 boxes, they have to be put into 2 different groups. Order of the groups is not important. Order of the groups is not important means the boxes are identical. Now, I have 10 people, I have to simply distribute them into 2 teams of sizes 5 and 5. Now, I am not naming the teams T, this is team A or this is team B. So, order among the teams is not important. I am putting 5 things into, 10 things into 2 identical boxes, 5 things each. So, order among the identical boxes will not be important. In that case, what you have to do? 2n factorial by first group is getting n things, second group is getting n things, n factorial into n factorial, and because the order is not important or the boxes are identical, you have to divide by 2 factorial. And whenever order of the groups is important, let us say 10 people, I am distributing them into 2 teams. One team is to be sent for a cricket tournament and another team is to be sent for a football tournament. In this case, which team is being sent where also becomes important. Order among the groups will be important, or the boxes are distinct boxes. In such case, the 2 factorial in the denominator is not needed. This will be similar to the previous result. So, whenever the sizes are equal, you just have to see whether the boxes are identical or not, or order among the groups is important or not. Let us say I have mn things all distinct and now I have to split them into m identical boxes or m different groups. Order of the groups is not important. In that case, what will I do? Each group will be getting how many things? N things. I am dividing mn things into m groups. So, each group will be containing n things. So, n factorial will come how many times? M times. That will be n factorial power m. And because the order of the groups is not important or the boxes are identical, I have to divide by m factorial. And if the order of the groups are important, that is you are dividing them among persons or you are putting them into different boxes, then that m factorial is not needed in the denominator. So, whenever the sizes are equal, you have to be careful whether the boxes are identical, order among the groups is important or not. Let us look at an example. Find the number of ways of dividing 100 cards into 2 groups of 60, 40 each. So, here sizes are unequal. So, happily you can do this 100 factorial by 60 factorial into 40 factorial. Next question. Find the number of ways of dividing 50 books into 2 groups of 25 each. 50 books into 2 groups. Simply you are dividing into 2 groups. So, here order is not important. You just have to divide them into 2 groups and they are equal 25 each. So, Because the order is not important, I am dividing by 2 factorial, 50 factorial by 20 factorial whole square into 2 factorial. Another question, at an election, 3 wards are to be canvassed by 3, 4 and 5 men respectively from 15 volunteers. So, from 15 volunteers, 3 volunteers are to be canvassing in one ward, another 4 volunteers will be canvassing in second ward, 5 men will be canvassing in the third ward, and what will the remaining people do? Take rest. So, there are 4 different categories of people now here who are canvassing in the ward 1, canvassing in ward 2, canvassing in ward 3 and taking rest. In how many ways they can be allotted? So, how many people are to be allotted for camp 1? 3, for camp 2? 4, for camp 3? 5, and how many will be left out after this? Total there are 15 men, of which 12 are being allotted. So, 3 are remaining unallotted. So, effectively you do not have 3 groups, but 4 groups, 3 for camp 1, 4 for camp 2, 5 for camp 3 and 3 who are not allotted. So, 15 factorial by 3 factorial into 4 factorial into 5 factorial into 3 factorial would be your answer. Next question, in how many ways 12 different books can be separated into 3 equal groups? 3 equal groups. In how many ways can they be distributed among 3 persons? When you are distributing among 3 persons, order will become important. And when you are simply separating into 3 groups, order will not be important. So, when you are separating into 3 groups, denominator will have 3 factorial. When you are distributing among persons, there will be no 3 factorial. So, what are the answers here? When you are distributing among groups, there will be 3 factorial, and when you are distributing among persons, there will be no 3 factorial. So, this is how we will be solving the questions. Another one, 20 different things are to be distributed among 4 boys such that a particular boy gets 8 things and the remaining boys get 4 things each. Remaining boys get 4 things each. So, a particular boy is getting 8 things. So, part of them are unequal sizes and part of them are equal sizes. So, how many of the boys are getting equal number of things? 3 boys. And because you are distributing among boys, they are not identical. So, equal or unequal does not matter. Simply the question would be 20 factorial by 8 factorial into 4 factorial whole cube. But same thing, find a number of ways of distributing 40 different things into 5 identical boxes. Here boxes are identical such that 2 boxes have 5 things each and remaining 3 have 10 things each. So, 2 boxes are of equal sizes, the remaining 3 boxes are of equal sizes. So, how do you treat this? There are total 40 things, 2 boxes have 5 things each. So, 2 5 factorials in the denominator, 3 have 10 things each. So, 3 10 factorials in the denominator. So, 40 factorial by 5 factorial whole square and 10 factorial whole cube, and because these 2 sizes are equal, I have to divide by 2 factorial, and because these 3 identical boxes are having same sizes, I have to divide by 3 factorial. This is how you can handle all the questions in divisions and distributions where the things are different and the sizes are given. Let us say the sizes are not given, then there will be 2 important varieties of questions. When you are distributing n distinct things among R boxes as you wish, empty boxes allowed. So, first thing I can put into any one of the R boxes, second thing I can put into any one of the R boxes, and third thing, there is no dependence here, and fourth thing. So, each and every thing can be put in any one of the R boxes in R ways. So, total this can be done in R power n ways when empty boxes are allowed and order within the box is not important. Okay? And if the empty boxes are not allowed, then this will be question on inclusion exclusion principle. You have to remove the cases where from R power n where you have distributed as you like. There may be cases where some boxes were left empty. You have to remove the case where one of the boxes left empty. Which box? Select that box, RC1 ways, and distribute among the remaining R minus 1 boxes in R minus 1 power n ways. and in inclusion and exclusion principle you will be subtracting the excess. So you have to add the cases where two boxes were empty, select the two boxes RC2 and distribute among the remaining two boxes, remaining R minus 2 boxes, R minus 2 power n, so on, continue till the boxes are empty, alternate plus minus sign. So whenever empty boxes are not allowed, you have to include inclusion exclusion principle. Inclusion exclusion principle, you will have a exclusive video on it. What about when things are identical? When things are identical and unsized, simply this will be a result of multinomial theorem. You can distribute n identical things into r distinct boxes in n plus r minus 1 c r minus 1 ways. So this result again we can discuss in detail in multinomial theorem video, which will be following this. And if the empty boxes are not allowed, then you can distribute n identical things into r distinct things in n minus 1 c r minus 1 ways. There will be furthermore lot of varieties of questions in this. All of them we will look at in multinomial videos. Stay tuned. And where do you use this n identical balls into r distinct boxes? Let's say you have r varieties of fruits and you have to collect n fruits from out of this r varieties of fruits in a supermarket. You can choose any number of oranges, any number of mangoes, any number of bananas, but the total has to be n. For example, your mom asks you to bring 10 fruits from any one of the given 5 varieties. Now the choice is with you, how many oranges, how many banana, how many guava, how many pineapple, how many watermelons you want to choose, but the total has to be 10. So in such case you will apply multinomial theorem. Let's say you want to score 250 marks in JEE, so you are allowed to lose 50 marks in JEE. Now this 50 marks, some of them come from physics, some of them can be from math, some of them can be from chemistry. Now the sum has to be 50. Some of the marks which you are losing from all the 3 subjects should be 50. Now it can be from any configuration. So how many different ways? That again is a result of multinomial theorem. Last part of it, divisions of distinct things when order within the box is also important. Order within the box. Right now we were simply distributing among persons or into boxes. We have not considered that the order within the box is important. Whenever the order within the box is important, how many ways you can distribute n distinct things into r boxes? It is n factorial into n plus r minus 1 c r minus 1 whenever empty boxes are allowed. So first I am deciding how many will go into each box. After deciding how many will go into each box, that is in n plus r minus 1 c r minus 1 ways. Now I am permuting all these n distinct ways things among themselves in n factorial ways. That is how you get n factorial into n plus r minus 1 c r minus 1. This is when empty boxes are allowed. If the empty boxes are not allowed, first you have to decide how many things are going into each of the boxes. That decision by multinomial theorem you can take in n minus 1 c r minus 1 ways, and once you have decided how many are going to each box, then you can permute all these n things among themselves in n factorial ways. So what will be the result? N factorial into n minus 1 c r minus 1. Now let us see, when will this be important, that the order among the group is also important. Let's say there are 3 queues before a cinema hall and 100 people are standing before these queues. Okay. Now it also becomes important they are standing in which order before the queue. So first decision you have to make is, before each queue how many people are standing. That conclusion you can come to a plus in 100 plus 3 minus 1 c 3 minus 1 ways if the empty groups are allowed. A queue can be left unattended. If empty groups are not allowed, you can do it in 100 minus 1 c 3 minus 1. Now once you know before each queue how many people are standing, you can permute all these people in 100 factorial. So what will be the result? 100 factorial into 100 plus 3 minus 1 c 3 minus 1 when empty groups are allowed in the queue. Another example is, you have 20 books and you have to put them into piles on your table. Now, it also becomes important the books are in which order. Maths book is below, or maths book is above, or physics book is below, or chemistry book is below. So, order among the pile will also be important. You are distributing 20 books into 3 piles on your table, 3 vertical columns on your table. Order in which the books are placed will also become important. So, in how many ways it can be done? 20 factorial into 20 plus 3 minus 1 C 3 minus 1. If it can be at most 3 piles. If it has to be exactly 3 piles, that is empty is not allowed, then it will become 20 factorial into 20 minus 1 C 3 minus 1. So, these are the set of all questions in divisions and distributions. Slide will be shared to you in the link below. If you like the video, like it and subscribe to the channel. All the very best.